Good morning, everybody. It's awesome to be here again. So,
The tech worked.
yeah, just before we begin, actually, I want to address something that happened yesterday. The website of DefCamp was DDoSed yesterday for a while. And the group behind that is a known Russian group named No Name 057. They simply don't like these kind of venues. They simply don't like that we talk about and share information and to defeat cybercrime. A lot of the cybercrime in the world today, or against the western part of the world today, is originating from Russia. It's supported by Russia. So there are a lot of things we do, a lot of good things we do that are not liked by the other parties. And we need really to be persistent about the things we are doing. We should never stop doing what we're doing here, because this is for the greater good.
It is. So, we're going to talk a little bit about legacy APIs in the realm of Entra ID and how we can leverage those to do stuff we're not supposed to. But let's start by talking about some threat actors that we've observed during our incident response engagements.
Yeah.
So this slide is basically the same one as we showed yesterday. This is an example of a not so low and slow kind of threat actor. You know, they don't really care that you know that they're there. They do everything noisy. They're popping alerts everywhere. They don't really care. But we also have other examples. But if we look at...
Yeah, we've seen all sorts of threat actors and their operations and tactics within environments. So the ones that are really caring about what they're doing in terms of they are at a higher sophistication level, they will visit an environment multiple times, not necessarily within a short period of time. Rather said, they will do that kind of actions on a very stretched type of time frame, right? So we typically see that there is one breach account. There is a phishing against one specific account. And then not much is happening on that side. They just go in there, do a quick recon, and then just exit. And the next time you would encounter them is not tomorrow, is not the next week. It's probably a few months or a few weeks from now. They will come back. They will probably target something totally different. They usually never go back to the original account. They will go to something totally different in that organization, and they will fill in the gaps with more information. They have already enumerated some information. They want to get more information on top of that. And then they will keep repeating that pattern. They will keep coming back, and every time they come back, they look at a totally different thing. There is no obvious relationship between the things they're doing. But when you start putting the dots together, and that's a lot of tedious work, then you clearly see, hey, this is somebody that was really interested about doing these kind of things about this part of the company. For instance, we've seen phishing towards one account, and then suddenly there's another account signing in via VPN service, where the VPN service is not doing MFA. So how would they know that these guys or this account, particular one, does have access to that service without touching it at first? So a lot of internal enumeration, a lot of these kind of activities that they put the dots together, draw the big map, and then see, oh, you know what? Our target is actually that R&D department over there. Well, let's start from a regular user, like regular office type of user working over here, and then take a step-by-step approach until we reach our final destination. We've been working with the Microsoft Dart team and other bigger incident response teams in the market, and it is really a difficult game unless there is a cooperation between big players. Because everybody will see a portion of the things that are happening, and we need definitely every time to help each other to fill in those gaps on our side to understand exactly what was happening. So this is, as said, this is another reminder, the slide from information brought from the Russian market, as you mentioned.
And so let's give a little background as to the toolkit that we've created and why we had a necessity of creating it. Well, when we're doing these incident response engagements, we need to get a lot of information about the environment that we're dealing with in an instant. So instead of having to click around and, hey, what's this setting? How many users are synced? How many whatever? How are their conditional access policy configured? We just want to scrape all of that data, dump it out so we can basically piece together, hey, this is what the environment looks like. Look for any signs of persistence, look for all of these things that we know that the threat actors are leveraging. And this is something that I developed during my spare time. So when I'm not occupied in an incident response engagement or helping customers proactively, we build stuff like this. And this also comes into play when we're dealing with, let's work proactively. Because what we're doing here is that we're basically acting like a threat actor, right? We're getting access to your environment, and boom, we know everything. But we're the good guys.
Yeah, and normally when we get engaged, we also put a bunch of requirements on what kind of access we would require. We say always that, hey, dear customer, give us as much access as possible. Simply give us global admin, root access, domain admin, etc. And the sole reason for that is that we want to do the job as quickly as possible. We don't have time to spend waiting for approval this, approval that. Give us as much access as possible, then we can run our tooling.
Yeah, exactly. So this little toolkit, if you want to call it like that, it provides us with just this. So it can dump conditional access policies. You can get a list of, hey, these are all the directory roles that are assigned to other users. I get that, yes, you can still do that using the native PowerShell modules. However, we just wrote a wrapper around it and, do all of this at once, please. And we can get some other information about users, groups, applications, whatever. And the reason for us choosing to target the AAD Graph API is because it's quicker to get running. I mean, I know it's in a deprecation path. It will get deprecated. Nestori promised me that next year it will get removed, revoked. But it's still there, and that's why we're still using it, because it still works.
Yeah, and that's also another reminder that just because there is a new API, a shinier one, or does a lot of nice things and so on, it doesn't mean nobody else is going to use the old one, right?
Exactly.
There are a lot of maybe good things buried within the old version of that same API because we didn't have that same level of security or privacy or whatever it could be with the old API.
So the graph deprecation is coming. It has been postponed at least twice now. So yes, until like May, June next year. Fingers crossed that it will actually get deprecated and destroyed by then, because it's really powerful. But let's look a little bit at, okay, this is a straight up out of the box API call towards, let's look at some conditional access policies. Okay? So provided that you have an access token as an administrator and you simply invoke the correct web request towards the correct API, you get all of the conditional access policies in a JSON output right in the prompt. And when I started working with this, I drew inspiration from Nestori's work with his powerful module AAD internals. And we could clearly correlate that, yeah, this is in fact a conditional access policy. We can see the policy ID correlates with what we're seeing directly from the API. And digging through the code, we can see that, yeah, this is what Nestori was doing in the first place. So it's nothing new, really. So let's take a quick look at, OK, what can we see using this type of raw method? So in this case, we're just grabbing a little access token, do some multi-factor authentication magic. construct our little headers. And we can actually enumerate a lot of the Entra ID tenant configuration using the direct API calls. So these are all the users in this demo tenant. We can see some authorization policies. But this is the one that we were most interested in. So let's look at conditional access policies. These are all the ones that exist in this particular tenant. And if we look at what do they contain, you can see that, yeah, this is a bunch of raw data. It doesn't really make sense because it's hard for us to understand, OK, what's this application ID? I know that I can look it up manually, but what we wanted to do is to streamline this into, let's not have to crunch the data one by one. So basically, what we did was something along this line. So we started crunching the data, and we figured out that, hey, we can actually read this in PowerShell. And we can see that in this particular conditional access policy, it's targeting a couple of roles. We don't know what the roles are because there's just a role ID or a GUID. But to just make a point of how the module or the commandlet works, we're basically splitting this string into separate strings, and then we're, get this role ID, get this one, and we're looping through them all. So if we were to connect via the real PowerShell module, and we'll try to go and grab this role ID, you'll see that it doesn't exist. Because that's not really a role ID.
Yeah. So there is a background story for this. Why does it behave like that? Is this expected? Well, yeah, it is expected. So when a tenant is created, there are a lot of artifacts that gets created that are just local, right? So if you look at our global admin and our tenant, or our company administrator, right? If you look from different perspectives, we're still looking at the same tenant. There's an Entra ID and there is an Office 365 space. They are named a little bit differently in the different, when you look at them from different places, but they're still the same entities. There are these kind of differences in scope. But also, my domain, my tenant will be different from your domain, your tenant. This is applicable for both on-prem stuff and cloud stuff. The display name will be read the same thing, but the actual object ID is not the same thing. We need to understand that there is something in the background that will tie all this together. So there are other types that will refer to the object we're looking at.
Yeah, and as I've shown you on the screen right now, so what we're dealing with when we're looking at conditional access policies, we're not actually dealing with the role itself. We're dealing with the template of the role. Because there's always these role templates for every role inside of Entra ID. And the IDs that we can scrape out of the conditional access policy is not the global admin role per se, but rather the template of the global admin role. Now, the template ID, that's the same in every tenant. So this ID that we see on the screen right here, that's the Azure Active Directory template, role template of the global administrator in any tenant. It's the same one. But if we were to look at what's the object ID of the role in this particular tenant, we could see that it's not the same one, and that's why we couldn't find it in the first place. Because this is a unique ID per tenant. However, if we were to use the older legacy MSOL module, it would get MSOL role. That would be the directory role template. So there's a lot of things going on, and we just need to be aware of the things that we see in the conditional access policies doesn't necessarily translate to the actual value itself inside of the tenant.
Which also gives the flexibility, because if you can make actually a conditional access policy exportable, importable, without the need to worry about, what is it named here? What's the object ID here? Just, hey, get this one imported in your tenant, everything will be fine.
Yep. Yeah, and that's one of the reasons that why we built this tool as well, because when we're called upon in an incident response engagement and everything's encrypted, it's kind of hard to get to grips on, hey, what's the Enter ID Connect configuration? How does that look? Well, we can use this type of tools to actually backwards or reverse engineer how the Enter ID Connect configuration was set up in the first place.
And in some still rare occasions, but they do exist, we actually have had the need to rebuild the system in terms of we need to build a new tenant based on the information we got in the current tenant. So exporting all the data this way and then importing it in the new tenant, and we know that, okay, this thing is going to fly. We're not referencing any impossible objects or things like that.
Yeah. So we can all agree that if you're privileged enough, you should be able to do this, right? If you're an administrator of the tenant, I should be able to do this. So if I'm a conditional access administrator or a global administrator or a security administrator, I should be able to do this. But I actually stumbled upon this when building this little nice wrapper, that I forgot to enter my global admin credentials and simply entered my regular user credentials. And yeah, you can do it as a regular user. And we need to be aware of this. So I retraced my steps. I documented everything. I reported it to the MSRC. I spoke to Nestori about it. He has already reported it. But I felt like maybe we could report it again. Maybe it'll actually do something about this. And their response was that this is by design. Sorry. I know it's a deprecated API. It's going out of business. But we won't do anything about it until it goes out of business, basically. So you guys need to be aware of this thing still works.
Yeah, so if we are building our security or defenses around, what we're doing some really nice, super duper secret stuff in our conditional access policy, we're blocking this geo-IP location, we're allowing this, that combo, this combo, etc. That's not a secret. If somebody actually managed to sign in, just as a regular user, it's until now, until like a year or half a year ahead, it's not a secret. If you are a legitimate user in the tenant, you will be able to read out that information and figure out the exact construction of policies and figure out, oh, you know what? If I go this direction, I can avoid that thingy they created over there.
Which is a really nice tool to have in terms of recon. Okay, what's my next target? You have a PAW policy. Okay, which device do I need to attack in order to gain full control over your tenant, et cetera, et cetera, et cetera. So let's take a look at...
Just on top of that, Viktor, I can imagine why the old API has looked that way. You guys who are familiar with Active Directory, the on-prem version of this, right? You know that in Active Directory, everything is available for everybody who's signed in. Right? There are no secrets in Active Directory except for the passwords. If you have enough admin level, then you can get the password as well, but it's at that level. No. So I think the design specs or the architecture behind the scenes have somehow been influenced by, oh, you know what? On-prem, we've been doing this for a couple of,
decades,
20, 30 years-ish. Why should we change it suddenly right now? Let's keep the same pattern and go on. And we've reached today's status where, yeah, but conditional access policy has become a critical component in our system, so we cannot afford having everybody having full insight in what's going on there. So we need to give them more protection or more kind of privacy.
So let's take a quick look at doing this as an end user in my tenant. I just want to show you that, yes, this is in fact an end user. You saw me logging in with this same account previously when we actually did this. But if we go to Entra ID, we look at security, conditional access is grayed out. I can't click on it. I'm not supposed to be able to read this. If we go back to the PowerShell prompt and we try this commandlet, you do not have enough privileges. So it's telling me I'm not privileged enough to perform this operation. But I just did. So with that in mind, let's try and resolve this output into something more readable. And let's actually run this little function that we created. Now, granted, this will take some time, depending on the number of policies, the number of users, et cetera, et cetera, et cetera. But we will get provided a response in the prompt, and we can use that to actually document how the conditional access policy framework is configured. Any minute now.
Yeah, hope the cloud will play.
I did provide some, progress bars previously, but my colleagues thought that, no, let's remove that. It's just a nuisance. We don't need that anymore. Come on.
Yeah,
there we go.
There we go.
So we have all of the conditional access policies. Now, as you saw, I don't have enough privileges to do this. I should not be able to do this. But here we are. All of the apps, all of the users, all of the settings, everything, bright as day, ready for us to reuse or retarget another poor victim in this particular organization and move laterally within the cloud.
Making life a little bit easier.
Make life a little bit easier, yes.
Yeah.
So this is all horrible and scary. What can we actually do to detect this happening in our tenant? Well, we figured out that we can actually leverage Microsoft 365 Defender or Microsoft Defender XDR and Custo query language to detect this. We tried detecting it via the diagnostic settings inside of Entra ID. We sent the graph activity logs to a log analytics workspace. Sadly, that only covers graph.microsoft.com endpoints, not graphwindows.net, which is the Azure AD ones. So we can detect it, but we need to be a little bit, we need to think of the English translation of it. But we need to come up with something smart to do it.
We can see that the user accessed the API, right? But there is no more extended logging in what's going on within the API. So that's where the thing stops.
So as you can see here, this tenant, it does have the Microsoft Graph activity log checked in. But if we run a query towards that particular I need to sign in again. My token has expired. Come on. Yeah, let's go back to the log analytics workspace and try to detect this. I do apologize for the demo blowing up in my face. Where is it? Here we go. So let's run this query towards the Microsoft Graph activity logs. We can identify that, no, these actions are not registered in here at all. OK? What about advanced hunting? Well, in this particular query, we have constructed it as such that if your user account does not contain, or you're not assigned to an Azure Active Directory administrative role, we want to see if you have logged in via the application ID, which translates to Azure Active Directory PowerShell successfully.
Yeah.
So let's run this query and see if we can get any results and try to find my nasty stuff that I've been doing. But as Hasain said, yes, we can see that there's an interactive sign-in event towards this application. However, there's no trace of which API was called, what were you doing, were you running a get, a set, an update? We can't see that. So we can identify that end users are doing this, but we can't really see what they're doing.
Yeah. Well, during investigations, there is always a bigger context, right? So when you now look at, I did this activity, how discoverable is this or not? But when we do an investigation, we always try to bind these things together. What does it mean if we're doing an investigation? What does it mean if we need to detect something? There are a lot of other activities, like happening just before or just after. So studying what's going on, what steps are going on in between or before and after, you can actually create a contextual understanding of, oh, what is this supposed to mean? And that's a very important piece to put together with this. It's not like, hey, one line will give you the complete storyline. You need to work on it and adding more information to get the whole picture, or as much as possible to construct that picture, to understand what somebody was actually trying to do here.
Yep. So yes, we can detect this. But as we said, we can only detect that it has happened or something has happened. We don't know what, how, when, or where. We just, you signed into Enter ID PowerShell, and that's what we can see. And this is an example of that particular custo query. Like we see the Azure Active Directory PowerShell, you see the application ID. I actually jumped ahead of time, but there's the query itself. So detection, yes. In terms of prevention, now I've made it with strike through that we can't prevent this until the API goes out of business. But what we can do is that we can focus on mitigating actions. So like we can use speed bumps inside of our tenant to make it harder for a threat actor to actually perform this type of action. That's basically all that we're doing. We can't be so naive to say that our tenant or our environment is so secure that nothing will ever hit us. All of these security tools, hardening, security configurations, they're just speed bumps to make it harder for the threat actor to achieve their end goal. And they'll just, hopefully, they'll give up and go away.
Yeah.
Sadly, towards another company, but yeah.
I mean, if somebody is really keen, if we're dealing with a high sophistication level of threat actor targeting our environment, we should really expect that they will try to enumerate this one way or the other, right? So we know that's super easy today to stand up a few proxies around the world just to defeat the GeoIP blocking policies per se, right? Breach into the on-prem side of the environment and see if that will give any sideways into this. So it becomes noisier, it becomes more struggle, and that's also part of the goal. I say if we cannot protect it 100%, which...
But if we go back to the first slide, like if we can make a sophisticated threat actor act like a not as sophisticated threat actor, then we've done great.
Exactly.
Because that means that we can detect them, we can actually stop them from executing their end goal in your environment.
And if you will take something with you you never thought about before, assume breach is a very good type of thinking structure, because we know no matter what we do, there is no 100% security unless you disconnect the cables, right? So there will be one or another way for somebody to get in, for somebody to breach. And we want to make sure that if we get breached, then we will have the possibility to detect that. We used to say it's an unfair game, right? It's like, back in the days, they said, oh, they only require one tiny glitch to get in, right? And then nowadays we say if we have ears and eyes on the systems, then we only require one wrong sidestep to detect them. And they are caught.
So the tables have turned on the threat actors, provided that your environment is monitored, someone is actually looking at these alerts, because then it's the other way around. The cat and mouse game just changed. So one of the mitigating actions that we can do, and I encourage all of you to do this in your Entra ID tenant, is to register the Azure Active Directory PowerShell client ID as an enterprise application. This is a first-party application, but if you still run the registered Azure AD application provided with the client ID, force it to have assignment required, you can block implicit access to Azure Active Directory PowerShell. Because by default, just as we talked earlier, if I just download the MS Online Services module or the Azure AD PowerShell modules, as an end user, I'm fully entitled to read stuff inside of this tenant. Now, there are ways that, yeah, we can block MSOL access. Sure, we can say to the authorization policy in the tenant that MSOL is no longer a go. You can't use this. That will block MSOL and MSOL only, not Azure AD. So there are two modules working with the same APIs, but the controls are different. And there's actually one other setting inside of the authorization policy that's called block users from read other users. You can switch that to true. Yes, but that will break pretty much everything inside of Microsoft 365. Because you can no longer add new members to a team. You can no longer share stuff inside of SharePoint or OneDrive, because that leverages, or did use to leverage, Azure AD Graph API. Sorry. So registering this application and only allowing explicit access, that's your best bet to prevent unauthorized access to this particular application. However, if we go into this tenant and we say that my user account is no longer eligible to use the Azure Active Directory PowerShell application, so Viktor, you're no longer trusted enough to do this. You've done a lot of bad things. Bye-bye. That still works because I'm still logged in with the previous token. However, if I were to try to connect again with the same user account, I'm not allowed. OK? Make sense? But there's always a but. The way that we do this is that we grab an access token, and we tell the Graph API that, hey, we want to grab an access token as the Azure Active Directory PowerShell module, or the application. So if we just change the client ID to another Office application, in this case, Office 365 management, like this. We go back here, and we grab a new access token. construct the headers once more. So I'm not using the Azure Active Directory PowerShell client ID anymore, and I can still do this. So as I said, there's no like perfect response to this. I can still enumerate these things. What are the conditional access policies? They're here. So if I were to move from the PowerShell module to look up all the users and instead crunch the data directly from the API response, I'm still able to do this. So the only real way to solve this is by destroying the APIs. Really. Because as you can see, even with these controls in place, we're blocking access to this application. You're not allowed in anymore. I'm still able to do this.
Well, that's part of the wonderful world of APIs, right? We think we restricted that to these clients, et cetera, but as far as there is yet another client ID that is still applicable, we can still access the same API with a different client ID, and all of a sudden the scope is... And no, we cannot block all of them. It's...
Well, if you start blocking like OneDrive, block that client ID, people will get upset. That makes sense. And another thing to point out here, and we haven't actually talked about it, but since this applies to end users, guest users can do this too. So B2B collaboration users, you invite another user to your tenant. You're like, hey, the default settings say you can read a bunch of stuff. Then I, as a guest user, can do all of this enumeration that I just showed you. Now, even if the guest setting is set to the most restrictive one, under circumstances, guests can still do this. In Entra ID, there is an attribute called member type. Sorry, user type. So if we look inside of a user over here, which is an internal one, properties, you can see user type says member. Okay? It means this is an internal account. It's hosted by us, it's our account. Yes. If we look at a guest user, we can see that user type guest. Anyone want to venture a guess as where these guest access policies, which user type they target? The guest one. So if by some reason one of your B2B collaboration users have been converted to member, they can do all the stuff that a member can. Even with the highest setting set inside of the guest access restrictions.
So a takeaway from this, or besides that, yeah, given certain circumstances, people can do things that can lead to bad things, right? I think we should expect that to happen anytime, any ways, in any environment. But I also would really encourage you to, just because there is a fancy something that we can use as a security boundary or boundary-ish, we call things as a security boundary if, unless you know enough information and you can actually bypass this thing, it's a stop, right? Even if there is something like that, even if we consider conditional access policies as something like a security boundary, we should not rely solely on having that as the single line of defense. There should be a lot more lines of defense from the, the big unknown, aka internet, to our most precious type of systems or data. So don't ever rely on just one line of defense. You need to have multiple of them, and then we need also to, going back to a zero breach mentality, we need to be ready to deal with a breach as soon as possible. Yes, we will get breached, but we can care and take care of it.
Yeah, exactly. So the same recommendations still apply. Yeah, we didn't list them as mitigations, but you need to work with, having phishing-resistant multi-factor authentication methods, leveraging all of these things because that's the only way you can get access, well, that will not prevent this from happening, but it will make it so much harder for a threat actor to do what I just did. So layers on the onion, think of it as all, they're all a part of a whole. Don't rely on any one of them as your single line.
Cool.
And that's pretty much it. So I hope we didn't give you any more nightmares, but
for now.
Thank you so much for listening. Thank you so much for attending the conference.
Thank you. Thank you. Thank you so much, Viktor and Hasain. And now I really hope that the caffeine have kicked in by now, so you are ready with our questions. Just raise your hands. Okay, we got 2 questions here.
Okay. Did you try this against other parts of the old Graph API other than conditional access policies? And is it applicable there as well?
Yes. Since the Azure AD Graph API, it's applicable wherever the Azure AD Graph API is applicable.
Okay.
Yep.
Thank you.
Sorry.
They actually bundle a lot of things under the name policies. So
yeah.
Conditional access policies are one set of policies that are there.
Correct.
Is any of this working in the Microsoft Graph API, the new version of this?
We've tried to reproduce it in Microsoft Graph, and it's not working in Microsoft Graph. Okay. You need to have dedicated API permissions, either assigned to you as a user or to the application itself, and then you need to have permissions to use the app. So when the transition is done, these APIs are bye-bye. It won't be as big of a thing anymore.
So the new APIs are more role-aware, exactly, explicit permission-aware and so on.
So just another one. You said in a few months this API will be deprecated, hopefully. That means that next year DefCamp will see another type of insights from you based on the new API, hopefully.
Let's see where this journey takes us, right? There are new challenges accepted. Right?
All right, thank you.
Thank you.
Hello. What about situations where you have app registrations and basically make the calls as another service principal during delegation, or maybe he was able to deploy Azure functions, Power Automate, and bypass, basically do step by step and basically making your investigation much harder. So my question is that possible, bypassing, or how you monitor and how you investigate that? Okay. How difficult is the investigation?
Yeah, if you're adding like applications or functions or anything, everything does have an identity binding in the background, right? So we deal with it as if it's just any other regular identity, but at the same time, we need also to start considering what kind of diagnostics logs, other logs does exist in those functions or the application scopes, right? So as far as you mentioned, oh, we have this as well, and okay, how much can you monitor in terms of that? There are some newer, fancier type of monitoring capabilities, Defender for Cloud, et cetera, that have started looking into that space. It's not fully accomplished yet, but we are getting there eventually. The journey has just started in that space. A lot of like recommendation style, this is a bit on the loose side, and then you need to, tighten it a little bit, but then real monitoring and real response, we're not yet there, 100%.